A vertical plate is submerged in water and we have to find the hydrostatic force. So this is what we have right here. This is the diagram. So we have a vertical plate which is in the shape of a circle. This is the water and it's submerged. It looks like it's submerged 4 meters underwater, and this plate has a radius of 8 meters. So we will have to find the hydrostatic force. So let's go ahead and do that. But before we can do that, we're gonna have to put this into an X and Y Cartesian plane. So let me go ahead and just draw this right now. So I'll be right back. So this is our Cartesian plane drawing. So we took the radius, and actually we put the circle centered at the origin, and we took the radius, which is 8 meters, and right here, this point up here where the circle crosses the y-axis, that is -8. Right here is also -8. That's +8, and that's +8. And don't forget to take into account the submersion, which is 4 meters. So 8 plus 4 is 12 meters. So from here to here, that's a total of 12 meters. So yeah, we're gonna have to make a rectangle here, and this rectangle is going to be basically the force, the hydrostatic force, like the sum of many rectangles, like this one, two, like all of this sum, all the sum has, just pretend there's a lot of rectangles right here, right? From here all the way to the top. That is going, the sum of that those rectangles is going to be the hydrostatic force. So we're just going to draw one rectangle right here, doesn't matter where, doesn't matter where, at any unspecific point right here. So that is going to be just some random point right here. It doesn't have to be in the center, it could be anywhere. So this will be the length of this rectangle. It's going to be x and x, 2x. Why? Because we divided the circle into a Cartesian plane. So that is why we have an x right here and an x right there. So the length of this rectangle is 2x. So yeah, let's go ahead and continue. So the hydrostatic force is given to us by the integral of a to b of density times the length times the depth dy. Again, integral is because we're taking the sum of all of these rectangles. So let's go ahead and do this integral. So we have the integral of a to b. What is a? Our a, we're taking the force from, well, the sum of the rectangles from -8 all the way to 8, right? So it's going to be your a to b. So that is going to be -8 to 8. The density, we're working in meters, the metric system. We're not working in the imperial system, which is going to be feet and inches. So in this case, the density is going to be given to you as 9,800. So 9,800 newtons, but we're not going to write the units just yet. So it's going to be 9,800 newtons. And the length, we are going to have to find the length. So the length is in terms of x. We need to find out what 1x is equal. So in order to find out what 1x is equal to, we're going to have to use the what do you call it? The equation of a circle. And what is the equation of a circle? Is x squared plus y squared equals r squared. And what is our r? Our radius is 8. What's 8 times 8? That's 64. 64, let's write here. 64 is equal to x squared plus y squared. And we want to find out what x is equal to. We want to find out what the length is equal to, and the length is equal to 2x. So let's find out what 1x is equal to. Yeah, let's find out what just this 1x is equal to. So in order to find out what 1x is equal to, we're just going to have to subtract y from both sides and take the square root. So that is x is equal to square root of 64 minus y squared. And we're going to leave that as a positive solution. It doesn't really make sense to take the negative one, the negative solution. So let's just leave it as positive. So x is equal to 64 minus y squared. So that's going to be what 1x is equal to. But we have 2 x's, right? So we're going to have to multiply this thing by 2. So the length is equal to 2 times the square root 64 minus y squared. Now what's our depth? Our depth is basically this stuff. Our depth is going to be basically just this is our depth, right? The whole thing is 12 meters, right? 12 meters minus whichever point this thing is at. So our depth is going to be, I don't know, let's just say this is your point Y. I forgot to label that, but let's just say that's Y. Any point in the Y coordinate. That is why I said that it doesn't matter where your rectangle is, because we cannot just say that's 0. No, we cannot say that. Y is going to be any generic point. So your depth is going to be 12 minus Y. We cannot just say your depth is 12 for sure. No, we cannot do that. We're just going to say it's 12 minus Y. It has to be any generic point. So your depth is 12 minus Y dy. Okay, so now what we're going to have to do is basically we're just going to have to solve this integral. But let's take out these two numbers out of the integral, because these two are, they are factors that we can move out. They won't be integrated. So this is 9,800 times 2. That will be 19,600. Integral -8 to 8 of a 900, root 64 minus y squared 12 minus y dy. Okay, so it's 19,600. Okay, so now what we're going to have to do is basically solve this integral. We are going to distribute this to the 12 and this to the y. So we're going to have to distribute, so that way you can have two integrals. So that'll be 19,600 times the integral -8 to 8 12y 64 minus y squared dy plus the integral. I'm just separating the integrals, by the way, because you can do that. -8 to 8 y 64 minus y squared dy. So that is going to be what your integrals will look like. So this if you see this is going to be a odd function, this one right here. That's going to be an odd function. Why? An odd function is basically just f of, let's say, negative y is going to give us negative f y, right? That's an odd function. Basically, if you just add, you plug in a negative y in there, that's just going to be negative y 64 minus y squared, right? If you plug in a negative y. So f of negative y, that's just it's going to give you this. And look at this, that's an odd function. And when we have an odd function just like that, we do not evaluate that integral because it's going to be a 0. So we don't need to evaluate this because since it's odd, it's going to go to 0. So we're not going to evaluate that. So this is just 0. So we only have to evaluate, hold on. Okay, so we only have to evaluate this one. So that makes it easier. So let's go ahead and evaluate this one. So again, it's a 19,600 integral of a -8 to 8 of 12 64 minus y squared. Let me just erase this one because it's just taking up room. All right, now we can evaluate. I erase it because it just took up room. It just goes to 0. So let's evaluate now. So this will be a, actually look, we can take out the 12. So let's go ahead and just rewrite this thing up here. So that'll be 19,600 times 12, because we can take that thing out, times 12, integral of -8 to 8 square root of 64 minus y squared dy. So now this will be a trig sub. So we're gonna have to, let's rewrite this as, let's just forget about this thing for a while. Let's put that thing in a cloud or something. Let's forget about this for a while. Let's just focus on this integral. So this integral can be rewritten as -8 to 8 of 8 squared minus y squared dy. So now we can go ahead and do a trig substitution. So we have to let y equals to, this is just trig sub, 8 sine of theta, 8 sine theta. Yeah, 8 sine theta. And then your dy is going to equal to 8 cosine theta d theta. Right? Your the derivative of that plus times d theta. So now let's go ahead and evaluate. So let's go ahead and evaluate. This will be integral of -8 to 8 of square root 8 squared minus 8 squared sine squared theta cosine d theta cos 8 cosine theta. Oops, sorry about that. I don't think you can see that. Okay, so that's just my integral. That is horribly messy. -8 to 8 square root of 8 squared minus 8 squared sine squared theta d theta 8 cosine theta. Looks to me like we can factor out a 8 squared from both sides. So let's go ahead and factor out the 8 squared. That's just gonna give us 1 minus sine squared, and right here is gonna be 8 squared factored. Oops. 1 minus sine squared. It's going to be 8 squared factored out. And look at that. We have a product here. And when we have a product, we have 8 squared. We can take the square root of that. So we can take this thing out of the square root. So this is just going to be -8 to 8 of the square root of 8 is just 8. So since this thing is a constant, we can just take it out of the square root, and then we're just left with the square root of 1 minus sine 2 theta times d theta. Actually, let's take out the 8 also. We can take out the 8, so this will be 8 times 8. That will be 64, but you get the idea. Cosine theta. So now that we have that, this is going to be equal to 1 minus sine squared theta. That's cosine squared theta. The square root of cosine squared theta is just going to be cosine theta. So this is going to be 64 -8 cosine squared theta. Yeah, cosine squared theta. Cosine theta times cosine theta times cosine theta is cosine squared theta d theta. Let me go ahead and make some room for this so we can evaluate that. So I made room. So remember, I told you not to forget about the 19,600 times 12. So and remember from we actually had this integral. So what I did here is I pulled out the 64 and I combined it with the 19,600 times 12. So we have times 64 now. So we're not gonna forget about that. So we can just get rid of that, and now we can go ahead and solve this integral. So now we can go ahead and solve this integral. So, and again, we're just going to multiply what we get here by that. So that's why I told you not to forget about that. And now we can pull out the 64 so we don't really get distracted. We can just have a nice little clean integral to work with. So let's go ahead and take our this cosine squared theta. Cosine squared theta is equal to 1/2 times 1 minus cosine 2 theta. Right? Oh wait, no, I'm sorry. There, plus. It's not minus, it's plus. Okay, so now we can basically just distribute the negative and have a easier integral to integrate. Actually no. Let's not distribute the negative. Let's rewrite this as -8 to 8. Let's pull out the 1/2. And now we're left with 1 plus cosine 2 theta d theta. Okay, so let's bring this up here so we don't have to be distracted with this 1/2. All right, so now we're just left with this, and this will be kind of easy to integrate. So when we integrate this, we're just gonna get theta plus cosine 2 theta. The antiderivative of that is gonna be 2. I'm gonna do this thing in my head. No, it's not 2. 1/2 sine 2 theta. Evaluate it. -8 to 8. Okay, so now that is what we have right now. And before I erased it to make room, remember that y is equal to 8 sine theta. So we have to draw the triangle. Sine is opposite over hypotenuse. Well, I mean, sine, what is sine? So opposite over hypotenuse, so it's opposite over hypotenuse, right? So this means that sine right here, divide by 8, divide by 8. Sine of theta is equal to y over 8. Opposite over hypotenuse. So now we can go ahead and basically use these substitutions into here, because we cannot just plug in -8 in where we have this theta and that theta. We cannot just plug in -8, right? So let's go ahead and do this. So basically we have to find out what theta is. What is theta? Let's take the arc sine of both sides. So let's take the arc sine of this. So arc sine of y over 8 is equal to theta, right? Arc sine of y over 8 is equal to theta, because we just took the arc sine of that. Because the sine of theta is going to be equal to y over 8, and then arc sine of y over 8 is going to equal to theta. So now we found theta. So yeah. So now let's go ahead and put this in here. So now we have arc sine y over 8 plus 1/2. Remember that sine of 2 theta is equal to 2 sine This is a trig identity, by the way. 2 sine theta cosine theta. 2 sine theta cosine theta. Remember that. So 1/2 is equal to 2 sine theta cosine theta. It's 2 sine. What is sine of theta? Using your triangle, SOHCAHTOA. So what is sine of theta? Sine is y/8. 2 sine of theta. Sine of theta is y/8. SOHCAHTOA. What's cosine? Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Cosine is this over 8. Root 64 minus y squared. Okay. So now let's go ahead. And evaluate all of this, all of that, from -8 to 8. So now what we can do now is just plug in, just like how we always do when we evaluate an integral. So let's plug these values in and let's see what we get. So after I plugged in the values, so after I plug in 8, I got pi over 2 minus, I plug in -8, negative pi over 2. You minus this by negative, basically just adding, you're gonna get pi. So once that we got pi, you want to multiply pi by this. Remember when we had this thing here? Don't forget about that. So let's go ahead and multiply pi by that. So plug that into your calculator. And let me just plug this into my calculator, see what I get. So I plugged this thing into my calculator and I got 2.36, about 2.36 times 10 to the 7 newtons. So that is what the answer should be according to your textbook. So that's what the answer should be. And yeah, that is how you solve this. And that is it. Thank you.